Well, thanks for taking the time to come see our presentation on test automation. Glad to know, I thought I was the only one who cared about this. So pretty sweet to have you all here. So I'm Brooks Robertson. I'm the dev lead for the open data team. These are my colleagues, Jeremy and Tom. And we're going to talk about testing. So I think the first thing I'm going to cover is just kind of the practical strategies for testing, where to invest. Tom's going to go into unit testing, and then Jeremy's going to cover browser-based web mapping application testing, so Selenium. All right. So starting off, the anatomy of a web application. This is pretty standard stuff. You have a UI, API, and usually a backend or business logic layer. So why test? People get upset when you build things and they don't work very well. So it's usually a pretty good idea to trust but verify that it works. You can manual test, but that's kind of ephemeral value. And once that feature is released, that effort is lost. So it's important to spend some time writing tests. And also, perception is sometimes different from reality. Things that look really sweet from where you're sitting actually don't work that well. And another aspect of testing that you want to include is the cost of bug discovery. The further you get away from your laptop, the closer you get to production, it becomes more and more expensive to deal with those things. To spend the time up front and begin testing and find those bugs early is a really good investment. So I'm going to talk briefly about something called the test pyramid. Why the test pyramid? I don't know. It's a triangle. It's cute. Everybody likes it. Actually, it's a nice way to visualize the benefits you get and the different kind of vectors that you can utilize to test your app. It kind of starts with the baseline with unit, and the value there is it's fast, rapid feedback. You can run them locally. It's deterministic, isolated, and it usually lives with the code. And these are probably the cheapest things that you can kind of spend your time on. They don't cover the whole app, but they cover very specific pieces. And this is usually the developer's first kind of line of tooling to ensure the features work properly. The next kind of piece to that is integration testing. If you think back to the anatomy of a web app, we talk about the API, the service layer. These are really good tests to test connectivity, protocol, if it's a secure connection, basic CRUD, and data integrity, or even access. So the next layer is the UI testing. This is usually characterized by end-to-end what the user is seeing. It's going through the client. It's on a full integration stack. It's not on somebody's laptop necessarily. These are more long-running. They're not as fast as integration or unit tests, but also very valuable. This also generally, this is kind of the pinnacle of the test pyramid most of the time. But there's another aspect to this that I thought was valuable to share, and that is performance testing. You kind of break that up into two different discrete kind of areas. You have the page rendering performance, and you have the server response time. The page rendering aspect of it is how long it takes to render in the browser. So do you have a problem with your DOM? Did you not minify your JavaScript libraries? Are you utilizing a CDN, things of that nature? There's a couple of really nice free sites, Web Page Test and pingdom.com. Web page test actually gives you details and a kind of a report card on all the different aspects of testing your page. It's really useful, pretty easy to use. The other side of performance testing is the server response. This is how quickly your application is responding to HTTP requests. This can be really valuable over time. You run this sparingly, but it's something that you utilize to get a evaluation of your performance at release. So, you have 200 requests per second on one release, and then you run these again for the next, and you're noticing a degradation. It doesn't really tell you where there's an issue, but it tells you that there is an issue, so you're not surprised, and you can kind of go a little bit deeper. So just in general, the cost as you climb the test pyramid, so to speak, raises. Unit tests, as I said, were very fast, very cheap. Developers can run these multiple times a day. Really valuable. They give feedback. Integrations are valuable as well. You don't want to run them quite as often. They're a little bit more expensive to write. You may need a back end for this. But then you go to UI. This is Selenium. This is very expensive. They're both long-running and challenging to write, but they also do a full integration. They test from front to back. Really valuable. And then you have performance. So who writes these tests? You can kind of split it up. Feature engineers, as I kind of referred to, will write unit tests. It's a really valuable tool. Integration. And if you're lucky enough and you have a QA engineer, as we do, he spends a lot of time writing UI and some performance tests. One kind of interesting thing is asking a feature engineer to write integration tests is pretty hilarious. They become withdrawn and sullen, and they may even shed a tear, and you just laugh. Yeah, these are ways to kind of split up, and you can run these and write them in parallel, and it's kind of covering all your bases. So where to get started? This really depends on a lot of different aspects. Most of it is around the maturity of your application. If this is a new app that it's not really being used by any users, you don't want to spend the time writing UI or performance tests. It's a waste. But if you have users, you're having regular releases, that's a great time to kind of move up that chain. But I think the really important takeaway here is start testing. It's an investment that begins to pay off. I've been saved so many times by writing good tests. It's very worthwhile. So with that, I'm going to hand this off to Tom, and he's going to go in depth on unit testing and some strategies.
Wow, that's not 5? Yeah, that's me, but it should not be. It's like the reverse.
About that one? No?
No, 5.
Oh.
5? Yeah.
Back to 5? Yeah. I pressed the button. So you want, because it's showing mine now.
Yeah, no, it's showing mine. It's just in presenter mode the wrong way.
Oh, okay. I'm sorry.
Oh boy. Sorry about this, people. But when I checked it before, should we have you go? Dare we do that?
I could. Sure.
Sorry about this. I usually use reveal, so I'm not the whole PowerPoint.
All right, am I coming through? Good.
Yeah.
Gonna Move over to the podium here. All right. Is that yours? Okay. So I'm going to be talking about browser-based web mapping application testing. Okay, all right. As Brooks mentioned, my kind of testing is near the top of the testing pyramid. Let's talk about the kinds of tests that I write. I'm writing Selenium WebDriver tests that drive the browser just like a user would. And interspersed with those, I'm doing screenshot comparisons. And I'll be talking about both of those approaches separately. With Selenium testing, you have basically a way of acting like a user, but maybe not quite as smart, so you have to give it some instructions. It does all the things that a user would do. And like with the hands, it moves around the site, moves the mouse, types things in. The eyes, it's looking at the page, making sure it has the right stuff. So we see something that's cloth-like. All right, I bet you can guess what this is now, right? So in my test, it says, if it doesn't have pants and it doesn't have a trunk, then it fails. All I care about is failures, because I'm a negative tester. Then finally, along with the way of doing those things, you need some control structure above that to make some decisions and do some reporting. I'm using RSpec, Ruby, but there are many other test frameworks you can use. And our suggestion is just to use something that you're comfortable with. Doesn't matter what, but often if it's the same language and development system that your developers use, that might be most convenient. And Selenium has bindings in many languages, most likely the one that you're using. These are the basic steps in a Selenium test flow. And now I'm going to show you a small program that illustrates each of the steps. It's a very basic program, but it does everything that a Selenium test does. The first thing we do is load in the library and initialize the driver, or instantiate it. Now with our hands, we navigate over to the software under test, the application we're testing, the web app, which is Google. Now we are locating an element. This is the eyes. We're looking for an element that has an attribute called name that has a value called Q for query. So that's a very simple locator to zero in on the DOM element that we're interested in interacting with, which we do here. We're typing something in and then pressing the Enter key. Here, we're looking at the output. We waited for the page to get redrawn with the result of our test, which was to go to the page, type it in, and press Enter. Now we're seeing if it has the right results. If it has toolsqa.com in it, then it's a pass. We report it. Otherwise, it's a failure. Finally, we quit the driver, and that is the end of the program. Now, visual regression testing is just a fancy word for screenshot comparisons. So the typical flow for this is you create a bunch of baseline screenshots. You vet it yourself. You say, this is what I'm expecting to get every time I run the program. Then in your testing, you perform the scenarios, you capture the screenshots again, and you use your screenshot comparison system to compare to your known good baseline. Also, you might think, well, what happens when the program changes and I've got a new baseline? All these systems have ways of saying, it may have looked like a failure, but actually this new output that I'm getting is now the new baseline. So visual testing, screenshot comparison is very easy. You just have this way of making screenshots and sending them off to your service and then comparing. And it's very powerful. Instead of having to look for every single little thing on the page, it just captures the whole page, and any differences will be noted, as we'll see in an example coming up. This is what, I'm using a free open source system called Spectre, which any of you can get. This will be listed in the resources section of our repo that we're going to publicize. So anyway, it's called SPEC, spelled SPECTRE. Here it is showing a baseline. Here is an example pass where the baseline is on the left, the observation is in the middle, and then the comparison, which is all gray because there is nothing to notice, is on the right. This is an example failure in screenshot comparison. You can see there's a bunch of words, doesn't matter what they are, they're wrong, and they're highlighted in red. And so when the test failure is reported, you'll go and look at this and you'll say, oh yeah, those words are wrong. Now this here is the real killer application. This is what really makes this appropriate for testing a web mapping application, because in this case, it was the image that was wrong, and Selenium does not have a way of going in and saying, are these pixels correct? So this adds a lot of power to Selenium testing. Some considerations you have are that, I don't know if you know this, but taking the same screenshot twice in a row will not give you two identical files. Because of dithering and the way the graphics cards work, there may be subtle subpixel differences. And another thing to think about is it captures everything in the window. So if there's let's say a timestamp that's going to be different every day you run the test, that is going to show up as a difference in the screenshot comparison. And finally, there's one thing that screenshot comparison is not good for, which is, for example, something that's not visible, like the target of a link. And here I'm gone on to the next slide. Does anybody see what's different between the previous one and this one? Here. Right, the timestamp. So if I was testing this and I saw a different value there, I would have to decide, is that something I want to ignore, or is that something that is going to be a failure? So to mitigate some of these problems, in the Spectre system that I have, you can adjust a fuzz factor, which gives it some tolerance for images being slightly different from each other, but still being considered to be passing. For that timestamp, there's an easy way in Selenium to run JavaScript, and you can run JavaScript to cause that field to be hidden right before you do the screenshot, so it won't be part of the comparison. You do that in the baseline and also in the observation phase. Another thing you can do is pay for a full-featured system, like this one that I'm referring to here, Applitools Eyes. It's very sophisticated. It has great facilities for, say, highlighting an area that you're not interested in, and it's a really high-powered tool. It also costs typically $100 to $500 a month, or you can buy some sort of enterprise agreement. And finally, for the problem of the invisible changes, well, screenshot comparison is just not appropriate. It's complementary, so you'd use Selenium to check the targets. Now, these cons apply to both these kinds of testing. They're expensive to write. Well, the Selenium is. Screenshot's pretty easy. They take a long time to run, and they do require maintenance. Just the other day, I had a developer change the thing I was using to locate a field, and I couldn't log in, and I couldn't continue my tests. My tests failed at the login stage, so I had to go and find that thing and check in the change for that. And because these tests are kind of expensive to write, you don't want to do them like the day that the software is designed. You want to wait till the software is somewhat stable so that when you write a test, you're not going to have to be rewriting it when they decide to change the flow, for example. You want to be selective in what to test. Tom is going to talk about testing modules inside a page, like say the selector. So I'm not going to write a Selenium test that makes sure that every single way I use a selector can work. I'm going to trust that that was tested at a lower level, and I may need to do it in order to go through the flow of my program, but that's not going to be the focus. Another thing to think about for selecting your tests is, where's your money being made? That's what you want to test. And it's possible to coordinate with the developers to get things to be more testable. If you can convince them, or if you're a developer, if you can put in IDs or unique class names or name attributes onto the things that the tester needs to interact with, then you'll be good. And there's this method called the page object model, where you abstract the functionality of different sections of your app, and then when something changes in that section, you just change it in one place. So, like Brooks said, an advantage of this is that you have full stack end-to-end testing. Another thing we haven't brought up is you can focus these tests on multiple browsers. IE 10, anyone? Okay. And by testing it in an environment that's like the one that you're going to deploy into, you're testing the deploy. If the deploy messed up and put different versions of an unexpected version, although it might have worked in dev, it's not going to work in that environment. So it's really great for testing that. And it exercises the web app the same way a user does. An example where in our application where this is very pertinent is when you download a file, you click a button, the front end, the web app, sends a request off to the back end. Sometime later, the back end responds. In the meantime, the front end, the web page, is actually running polling to the back end. And that's something that it's an interaction. This system is the front end and the back end, and the only way you're going to test that adequately and accurately is in this system, in an integration environment. Now, let me show you. I've made a couple of movies because I didn't trust my ability to do a live demo here, but I'm going to show you a couple of scenarios. In this section, I am running a Selenium test, and you can see, is this not coming up? Oh, I don't know why it's not showing. Maybe, let's see. Full screen? Yeah, oh, it's PowerPoint, but it's not in PowerPoint.
Okay. You might, but is PowerPoint on? Can you turn it off? Can you turn PowerPoint off?
Yeah, I get PowerPoint
Okay.
on the full screen.
All right. Bye-bye, PowerPoint.
Okay, yeah, they're seeing that. It's an issue. You can get to your...
I don't know. Should I save it? All right. Can you see my movie now? Okay, great. Thank you. So I'm going to speed through some of the setup here where it's actually creating the website on which it's running. It's valuable tests, but it's not what we're focusing on. Now recall in this test, we are, here we go. Oop. In this test, I've simulated having, whoops. I've simulated having the wrong locale. So the words are in Finnish, and that is what the Selenium test is going to detect. Here we go. You can see it says expected data observed aineisto or something like that. So the DOM element was there, but the value was not as expected. So the Selenium test is going to fail as expected because it's displaying the wrong language. Now, I'm going to show you an example of the screenshot or the screenshot comparison. Same thing. Here's the website that it's going to go to. It's going to the page. It's drawing this screen. It's going to take a screenshot of it. I think we can go from here. Selenium is passing because all of the words are correct. Now it's going to zoom in. Looks good to me, right? Does anybody see what's wrong with that? What's wrong is a subtle problem with the geometry. Could be a wrong projection, could be that things are shifted over a little bit. The key is that A, this is not something that a human is going to even notice, and B, it's not something that you can even find with Selenium. However, let's just move on here. All right, now it's just deleting the thing, deleting the website. All right, so as you can see, it's saying that the screenshot failed. And now we're going to go in and look at oh, there we go. So the DOM passed, the words had the correct values, but the screenshot failed. Now I'm going to go in and look at run number 95 here. That's the last run. This is the first screenshot that was taken, the one before I zoomed in. Whoops. And now I'm clicking on to see what the failure was. Ah, look at that. This is something nobody would have noticed, but until the customer reported your bug to you. There it is, looks fine. Now let's look at see, everything was shifted over, and that's what it found. And that is the key real value of the screenshot comparison, that it finds things that we wouldn't have found by either eyeballing it or by with Selenium. So that's my part of the presentation, and I'll hand it over to Tom now. You ready?
Okay. Sorry about that, guys. Looks great here. Hope you can see them at all there, and you'll know what's coming, which is kind of a nice little side benefit. Unless we have any PowerPoint gurus in the house that know the one click that I'm not doing. All right, so yeah, I'm going to talk about front-end unit tests and component tests. On that, the pyramid that you saw before that Brooks was showing, we're going to be talking about the bottom half. The thing about that bottom half is you can split it in half between front end and back end. And, oh God, that just sucks. You guys can see that. Oh. Any? Ta-da! Who is that right there? Can you raise your hand? I'm going to buy you a beer, or whatever you want. So, okay, I'm feeling a lot better now with this. It's so these kind of tests, unit tests and component tests or integration tests, can be run either on the front end and the back end. What I mean by that is if you have a back end that's say written in Ruby, you can be writing unit tests for your Ruby code. And the front end, you've got JavaScript, you can be writing front end JavaScript code. So some of the, as far as the unit test goes, some of the stuff that I'm going to talk about applies in both places. We don't have anybody here representing the people that are writing our back end unit tests or anything like that. There's already 3 of us, so how many more people do you want to see talk about testing? So I'm going to be talking about the front end. As you can tell from my total lack of ability to do PowerPoint, I'm so JavaScript it hurts. I normally do my slides in JavaScript, so let's dive right into that. So unit test, you are testing a unit of code. What's a unit? A unit is effectively what you define it as. It can be something as small as a single function. It could be a module that has few functions, class. The main idea is that you're testing it in isolation from other parts of your system. What do you think the primary value of unit testing is? You might be thinking something like make sure the code works or make sure that you catch regressions. But really the primary value of unit testing is to help you derive good application architecture. And that may seem a little odd because yes, unit tests do help you write code that works. They do help you catch regressions, but because they run in isolation, it's only for regressions in that little area of code. They don't help you catch regressions in the whole system. That's really the strength of the kind of testing that Jeremy showed you. So it's really good to have in your testing approach this kind of 1-2 punch. Have a few smoke tests at the top that help catch regressions of the whole system, but then some detailed tests down at the unit tests. Now, let's talk about how can a unit test possibly help you, have better application architecture. Well, your typical web mapping application is going to do something like this. It's going to have a map. It's going to talk to a legend or a layer list. The layer list is going to be able to click on it. It's going to talk to the map. There's going to be a toolbar that can interact with the map. That's going to talk to the map. And then once something changes from the tools on the map, that's going to have to update the legend. And someone's going to throw a modal in there. The modal is going to talk to everybody. And pretty soon, you're just going to have this spaghetti architecture. And you're probably wondering how in the world can a unit test help with that? Well, let's think about the sort of 4 main principles that you should be following when you're doing unit tests, and that'll help us understand this. The first is you want to write high-value tests. You can write tests for anything, but you really only, we all have limited finite time and resources. We want to write tests for the stuff that's important. You only want to test your code. If you're bringing in third-party dependencies like, say, a mapping library, you don't want to write tests that cover their code. You only want to test one thing at a time. Now, this is something that only applies to unit tests. This is that isolation. When you're doing the Selenium test, it's pretty common, or even the component test I'm going to show in a little bit, to have several things happen and make multiple assertions in a single test. But in unit tests, you really only want to test one thing at a time. And once you've done that, that gives you the ability, the freedom to start refactoring your code and sort of honing in on exactly the right algorithms and getting things to work. So, back to our spaghetti application. If you opened up any single file in that application, it probably looks a lot like this. In fact, it may even have more of a nested pyramid of doom as it goes in and in, as everything's all wound inside of nested blocks of if statements and all that. We want to only test one thing at a time. How can you do that with this code? You can't. What we can do is start to break this code into sort of logic statements and then blocks of action. So the logic statements will be your control statements, your if, your for loops. It'll be maybe even asynchronous calls, and then the blocks are what's inside of the then, or what's inside of the if, and all of that. And what you want to do is, when you have this separation, we can start talking about how you test each of those sides, because you're going to do different kinds of testing. So for those action blocks, those action functions, they typically tend to be easy to test. In fact, quite often too easy to test. It's something, if it's just some input in and you expect some output, it may be something that, may not even be worth testing. Remember, we want to write high value tests. There are certain of these action functions that we can get a lot of value, though. We get real high value out of testing, and that's when the algorithm within it is fairly complicated, especially when you don't know the algorithm ahead of time. And you're something that this kind of test is tests you're going to write, sort of at the beginning of your development, and something that you can benefit from actually doing test-driven development. We'll take a look at it. So what I mean is, don't test this function. Right? Don't spend time writing a test for this. It's not going to break. It's not going to change. If this function, was just a placeholder, you're going to add more complicated logic later, sure. But if this is the end-all be-all of what this thing's going to do in its life, we don't want to test that. So I will show you a demo now of the kind of things where you can get some value out of this kind of testing. Switch over and hope that this works. Yay! Okay, this is our open data application. And you can see here, this is our dataset details page. When you land on it, it shows a map of the features of the dataset. And then a description of it. And then there's this area here with these attributes. And if you look at the attributes, we see that some of them have this little, maybe hard to see, but it's a little indicator showing that you can make a chart out of that field. So if you click on it, it's going to quickly throw up a chart. That's the intent of this page is to help people understand the nature of this data set. This application is about data discovery. So the charts that we're going to show here are about the distribution of the data. And what we wanted to do with this is we wanted to make this something where we could do something smart. We would be smart about the charts that we showed people. So you'll notice that some of these fields don't have that indicator. You're not able to do a chart on that. And that's because we've decided that we don't have enough criteria. We don't know enough about that field to generate a smart chart. So what does it take to generate a smart chart? Well, it's based on a few different factors. It's based on the type of the field. Is it a date, string, numeric field? If it's a string field and there are less than 20 distinct types, then we can draw a categorical chart of that. If there are more than 20 distinct types, it's going to go off the edge of the screen and it's not useful. If it's a numeric or date field, we want to understand the histogram of the data before we plot it. We want to have some stats on it. And our open data backend does some computing and caching of stats on certain data sets, but it doesn't do it on all of them. So if we don't have stats, we're not going to draw a chart. If it's a date field, we have to do some even more interesting things. We have to decide what's the full range of the date. If it's more than a year, if it's more than 5 years, we're going to show the date at year bins. We're going to bin the data by year. If it's less than a year, we're going to bin it by month, so up to 12, and on and on and on. So there's a whole bunch of criteria that go into the decision making in this, and it breaks out into a few functions, but the API is exposed to this application pretty much as a single function that says, should I chart this field or not? And you pass in the information you have about the field, the stats, the type, and the maximum number of records, and it goes through this algorithm, decides whether or not to do it. Well, the thing is about that is that we didn't know all the characteristics of that algorithm when we set out. We knew, for example, the text thing. We knew that one condition. We knew another condition about having stats, but we didn't know some of the stuff about the date field. And so what we did is something that I've heard this term used before. I really like the idea of this. It's called triangulating an algorithm. You have a known condition where you expect something to happen. You have another known condition where you expect something else, and then something else, and you just start writing tests for those conditions, and you build the code inside the function based on those tests. And as you can see from the the lack of not all of our fields are chartable, we still have work to do. We still don't know all the parameters of this, but we can evolve it over time and safely know that we're not going to break the previously known good conditions. So what I'm going to show you real quick is a test of that, the actual unit tests that run that. So make sure I'm on the right thing. And there's nothing more exciting than watching unit tests run. Maybe a little more exciting than Selenium test. But, and so what you see there is the main function that we're interested in is this should chart attribute, and it has these other helper functions that it calls. And you can see just the kind of criteria from if there's no stats, it should say return false. If this, and these are, each of these conditions are things that we built up over time. And so that's one of these areas where testing a purely action function that's not part of your application logic can be really useful. Unit testing can be really useful here. All right, so let's go back to PowerPoint, and what's the magical thing I need to do here? Play from current slide. Hope. Yay! Okay, so back to our separation of the action code from the logic code. So that logic code's at the top there. And this is really where your applications, this is where bugs happen in your applications, is this logic. And it's hard to test because it's hard to isolate this logic, right? It's got these dependencies of this action blocks beneath it. But if you're able to write tests of this code, they're all high value. So, and the way we test this is, we say if we give that, that sort of logic block up, these conditions, was function 1 called with these parameters, A and C? And did function 3 call function 4? Now how do we do that? Well, we use something called spies and fakes. We use testing libraries that provide ways for us to either wrap those action functions, the orange blocks, with a function that counts how many times they were called and the parameters that were sent, or even stubs them, completely mocks them out so that they're not actually called. So, how does that apply to maps? Don't test maps. I'm done. Thank you. Let's go back to that spaghetti application. Each of the blue dots here represents an attempt or some part of the application, a touch point where the application has access to the map. It's either setting properties or receiving events. This application could benefit from separation of concerns. One way to do this is to use a framework. That'll help you out with this. We're going to use a framework that came out yesterday. We're going to call it, anyone, JavaScript framework name? I'm going to throw one out there. Blah, blah. Okay, we're going to use framework blah, blah. And that separates the component controllers from, the UI components from controllers. Is some stateless or some UI-less piece of code. And we're going to move all of those those points where they touch the map out of the UI code. All right, the components themselves are just going to throw up events that are going to be handled by the controller, and the controller is going to be able to somehow do something with that, interact with the map. And the way the controller is going to be able to do that is through some central point. We're going to call it a map service. You might call it a map controller. It kind of just depends on what framework you're using, but the idea is that this is a piece of code or one module in your whole system that has access to the map. It's a facade. It's going to expose methods like new map and on to represent the events. It's going to expose show layer and destroy map. Now, that might seem a little redundant because you could just, these are very thin wrappers around the map component from our API that you're used to. And they're going to be relayed down there. And while that may seem redundant, what that's going to enable you to do is use spies and fakes for your map service. So let's talk again about a spy is something that essentially observes a function and lets you know how many times it was called, what parameters were sent. A fake, or also known as a stub, is actually going to replace the implementation of that function. And it can replace it with a no-op function. It can replace it with your own function that does something, some mock code that will help your testing environment simulate what would happen if that other function would call. And fakes usually also include the ability to do that spying, to count how many times they were called and let you know the parameters. So let's go back to our map service. In this case, we've got a little bit of code here that's using a library, a faking library called sign-on, but there are others that doesn't have to use that. And we're going to say, hey, sign-on, you should stub the new map function from the map service. And then whatever controller we're testing at that point, we're going to call its show map method. And then we're going to say, hey, map service stub, was the new map method called? Okay, great. That's what we're going to consider a passing test. And when that happens, no map was actually created underneath the hood. No tiles were hurt during the operation of this test. No features were pulled. You can run this test very quickly, repeatedly, over and over again, in a watch as you're coding every time you save your file, and you don't have to worry about your test framework generating these maps and doing all kinds of things in the background. So we'll take a quick look at a demo for this. Terminal. This is from, I should show you the application that we're testing first, while that's booting up. So this is an application we built together. So I see a few of you are here from the workshop on Monday. It's a very simple application that it's really a demo application. You can do a search against ArcGIS Online items, and then it returns a list and shows them on a map. And what we want to do is write a test for this map component here. That map component's talking to a map service that we've created in this application that does that thin wrapping around the JavaScript API. And we're going to stub out the methods of that map service, and so that the component test for that map does not actually call or request any, does not actually cause a new map to be created in the DOM. So, all right, go back here. Oops, close that guy. Sorry. So this is before we've added this stubbing code. What I'm going to do is show you what the test does. So we want to filter to integ. All right. Okay, so the tests for this map are here, and so we have two tests that run, and what we're going to do is inspect the network traffic for this. Hopefully it's not too small over there. We're going to, for ArcGIS Online. And we see that the map service itself, during the execution of this test, has been called 4 times. So now we're going to go back and we're going to update the going to update the code of this test so that we're going to get a reference to that map service, and we're going to stub out the new map function, just like we talked about before. We're going to render that map component, and we're going to re-inspect the network traffic and verify that no requests were made. All right, it takes a little to hone in on just that one test. So now we have a new test called was new map. What we expected was that new map was called once. It passed. We go to network. We search for ArcGIS. Oh yes, online. And we see that no, the map was never actually injected into the DOM. We've just completely stubbed that out. And so that's what's going to be helpful to you in having, make your test run fast and make it so that you don't have any problems with your test environment.
I'll make sure the map's okay.
Yeah, and I can do that because I can rely on Jeremy to create a test that's going to go in and at some point say, hey, was there a map? So, all right. I'll take a quick note here to talk about frameworks, test frameworks on the front end. It's kind of like Jeremy said, there are many of them. I've actually used every single one on this slide. Which one's right for you? I would say the first criteria that you should use is which testing framework kind of goes with whatever JavaScript framework you're using. If you're using Dojo, probably start looking at the intern. If you're using Angular, you probably want to start looking at Karma and Protractor. If you're using React, you probably want to look at Jest. So just start with whatever kind of framework you're using. Use use the one, start by checking out the one that goes with that framework. But at the end of the day, just use whatever works for you. When I was doing Dojo code, I wasn't really fond of the intern, and I was able to use Karma with it. There's these test frameworks, they all have a lot of idiosyncrasies. I'm not going to tell you they're all the same, but at the end of the day, you're able to wrangle them to do whatever you need them to do. Just use whatever, make sure you use a testing framework. So when you write unit tests, it's going to make your code better. It's going to make you code better. The code, when you have testable code, it's going to be more robust, more understandable, something that's easier to read about when it's broken into smaller pieces, more modular, and that makes it more shareable and reusable. I'm going to take a quick moment here to talk about component tests. I just showed you one. A component test is something in between the sort of pure unit test at one end of the spectrum and the complete end-to-end test on the other. So component tests, they're like mini end-to-end tests. They do mimic user interaction, but only for a part of the page. So in this case, we're going to focus on this header settings component. And the way a component test will work is it will inject that component into the DOM and actually start poking at it and pushing at it and ask it questions about its behavior. But that's going to be the only thing in the DOM. So everything else that's in the gray there will not actually be in the DOM while the component tests run. So we have partial isolation. So we're testing that UI component. We're probably going to have a fake or a mocked service of some kind to keep us from actually touching our API or anything else, right? We don't want to write an end-to-end test with this. We want to make sure that we don't engage those parts of the system. We may actually bring in other parts of the front-end application, maybe some config or utility functions, or your app infrastructure may need to be involved just to get that component on the page, depending on what application framework you're using. So the main thing is we really want to, with these component tests, we either want to avoid at all calling expensive operations like asynchronous server-side calls or fake them. The framework we use is Ember. It makes this easy. Whenever you generate a new component, it automatically scaffolds out a component test, and that's actually what we saw earlier. But that just your mileage may vary. It just depends on which application framework you're using. They may kind of give you the support or not. If your application framework doesn't do that for you, you might not be writing a lot of these. We write a lot of these, but it can be hard to set this kind of thing up. I've done it with Dojo before. It takes a lot more elbow grease. So that's all we have for you today. We've got a GitHub repository up that's going to have links to resources of everything that we've talked about. The source code for the demos I showed will be linked off of that repository. They're not in that repository. I think Jeremy put a snippet of generic end-to-end testing in that Selenium test in that repository. And we still have a few minutes, 5 minutes, if anyone has questions. And I do apologize about the technical difficulties. We survived it though. Oh, yes, sir.
So when you're writing these tests, how do you approach, say, mobile development where there's going to be a different device screen size that's may not be known in advance?
Yeah, the question is how do we handle like mobile device emulation for end-to-end tests?
We don't. It's just a web app. To check for some of that, we can do test. It's a responsive web app, so we can just set the dimensions to what we expect a mobile device would be, but that's about it. We're not really focusing on mobile. You can, these systems like, I think Browser Stack has simulators and actual devices on the other side. So combined with Selenium and Appium, you can get those things tested. But we are not doing that right now. But you would use something like Browser Stack. I've heard very good things about them.
Anyone else? Yes, sir. Yeah, the question is, do we have a rule of thumb for what counts as too much testing? I think it's really about, especially in unit tests, it's about if you're talking about code that is data in, data out. That's one area where you really run into this danger of it being too much testing. You don't want to write those for simple functions. Don't bother writing tests, right? If you're going to write them and not change them, I wouldn't write tests. For the kind of logic, those kind of things where you're mocking and faking things out, that's almost always useful. So, I do find myself in this situation of writing too much tests. Actually, I find the thing is the component test. So with the Ember framework, you can get into writing tests. You can start testing the framework really quickly because it's really about data binding, and so you pass properties in, and it's like, is that what showed on the screen? It's like, wait, none of my logic is in between the property I passed in and it's showing in the DOM. It's just the framework's just doing the data binding. So I actually find myself in more trouble in the component test land than unit tests. Unit tests, I really only start, as soon as I start looking at something and it's got like an algorithm, is when I'm like, okay, we want to unit test this. And the other thing is, another example is if you are doing a function that converts data from one format to another, and you think, I don't need a test, and you go write it, and then as soon as you get a bug on that, right, the format came back from the server in a different way than you expected, that's a good time to write a test. So write your happy path test, write this exception test, because guess what, there's probably more exceptions that you didn't think of. So that's usually a flag that says, okay, I'm going to write a test for this section of code. So when bugs come in, is a good time. So these days, I try to not write a whole bunch of tests. Like our pyramid actually looks like this. It's kind of like a Washington monument. is really what our pyramid looks like. And then we start building out the unit tests in areas where we have algorithmic kind of code or where bugs have come in. It's a great question. So the question is, for end-to-end tests, how do you, if you're doing CRUD, if you're testing CRUD operations, how do you maintain the data or get your environment set up?
Well, we create the item at the beginning, and we know what it's supposed to look like, so we look at it, and then we delete it. However, we do have some canned data that we use in order to cut down on the amount of creation of websites at the beginning, and we're not handling it in an extremely good way, but we just have it canned and it's in an environment file. So that's what we're doing right now.
Yep. Yep. So the question is how we do performance testing.
Actually, this is something that will probably be in the resources. I set up a little Docker project that incorporates JMeter. There's tons of performance testing tools out there, HTTPerf, Apache Bench. There's tons of things out there, but from the standpoint of depending on what you want to test, paging, you can do siege tests. Right now, I just wrote a simple script that rolls over all of our sites and then runs a certain number of runs against each URL. And I take that data and I throw it into Elasticsearch. That's actually part of the Docker repo. So you can basically have a CSV of URLs, how many times you want the URLs tested, and the results will be thrown in through Logstash into Elasticsearch, and you can use Kibana to view and visualize the test runs.
Yep. So yeah, I mean, it depends on what context you're in. If you're in that sort of front-end context, don't, is the short answer. Try to avoid it. Try to stub that stuff out. Assume that whatever library you're using to make async AHR calls will work and the backend will work. If you're doing the full stack testing though.
Right, that's an excellent question.
Yeah, so he's got a question about how do you simulate real-life testing. This is something we haven't done in, I'll let Jeremy talk to that about automated, but just haven't done this in an automated way, but we've done that where we just go set the bandwidth stuff in Chrome and run it as a user, but maybe Jeremy has a way of automating that.
Right. There are proxies you can set up and things you can put in the middle to slow down the data rate. We're not doing that right now. But we are sort of implicitly testing it in the end-to-end test because our pages are extremely asynchronous. The page loads, but then all the elements pop in over time. And my tests have to allow for the fact that things aren't there immediately. But they can't wait forever, and I don't want to do a wait for 5 seconds before I look at each element. So I have configuration in the test that says, I'm going to wait up to 5 seconds for this to show up. And if it doesn't show up within that amount of time, I mean, if it shows up in 1 second, then I can verify it. I have to wait a certain amount of time, and at a certain point, the test fails. So it's sort of implicitly testing it, but that's an area that we need to work more on is poor network performance and how does the customer see it in under that condition. We don't do it right now.
Any other questions? Are you guys all just waiting for the next talk? if you want, you can, if there's no other questions you want to ask in front of everybody, then we can all go and say goodbye and thank you very much. And then I have nothing else for the rest of the day. If anyone has any questions for me, I don't know about these guys. You have another talk, right? You got to get out of here. But thank you very much. Yeah.